In this video, we're going to be talking about section 1.2 part 2, and this is continuing our discussion on solving equations. And today we're just going to step it up a little bit and do two-step equations. So to start off, let's just do a quick warm-up. And again, it's not that these problems are difficult. What we want to do is really focus on how we think about these and how we do our work so that when the problems get super difficult, we will know exactly what to do. All right, so in this case, once again, we have an x minus 11 or x plus a negative 11, and the opposite of subtracting 11 is to add an 11. And again, why is that important? Because then that gives us x plus 0. And again, we don't usually write this line. In fact, I'll just erase it in just a minute. And why is x plus 0 important? Because x plus 0 is just x. And so we use the inverse, the additive inverse, the plus 11, to get the identity, x plus 0, and then x plus 0 leaves us with x, which was our goal. All right, but usually we just know that it's 0, and we don't write that. So we bring the x down, equals what we do on one side, we do on both sides. Negative 48 plus 11 is going to be a negative answer, and to get the number, I'm going to subtract. I get 7, and I get 3, negative 37. Again, if you're going to use your calculator on that, please go ahead and just realize it's negative and then just do 48 minus 11 and get the answer. All right, this problem, yes, dividing by 5 is appropriate, but I want us to train our brain not to think about dividing. In fact, division can kind of go away, and we can always just think in terms of multiplying by the reciprocal. All right, so just to make sure I have enough room, I'm just going to rewrite the problem. And then I'm going to multiply by the reciprocal of 5. So the reciprocal of 5 is 1/5. So I'm going to multiply by 1/5 on both sides. And 1/5 of 5 is 1. So I have 1 times d. And why is that important? Because just like x plus 0, 1 times d is called the multiplicative identity. And it leaves us with just d equals, which was our goal. Again, we don't usually write that step. We just know that the 5s cancel, and I get d equals, and now I have 120 over 5, or 120 divided by 5, which is going to be, let's see, 5 goes into 12 2 times, 2 more, looks like 24. Put a box around it, know where the answer is, everything's clear. All right, and so why, again, do we talk about multiplying by the reciprocal instead of division? And the answer is right here. Because if we train you to always divide, then you're going to want to divide right here, and then you get this mess. And this mess is quite literally a mess. So we want to avoid this situation where we get a complex fraction because they're just more complicated. So instead, that's why we've taught you, don't divide, multiply by the reciprocal instead, because that is the same thing as dividing, and it avoids that awkward situation. So 3's cancel, 2's cancel, and I'm left with x equals 18 over 2, which is 9. And that's what we do. All right, so moving on to today's lesson, we're going to be talking about doing two-step equations. So really exactly the same thing we did before, but just doing them in, both situations occur in the same equation. All right, so example, these equations require us to take 2 steps to solve. The order is important. Think about our wrapping, unwrapping present example and how it relates to the order of operations. All right, so just with that in mind, that order matters. If I knew what x was, so if I was sitting here with the situation of negative 12x minus 7, and I said, hey, let's let x equal 2, for example, then we would plug the 2 in right here. And the first thing we would do is we would multiply by the negative 12. And the last thing we would do is subtract 7. Well, when we are wrapping a present, it's like following the order of operations. But solving an equation is like unwrapping the present. And so we just have to do it in the opposite order. Now, I don't want to get too fancy with it. There's always room for creativity and doing things a little bit different. But by and large, the order in a two-step equation where you have a multiplication and a subtraction or addition is you're going to deal with the addition first. So we're always going to move this 7 out of here. So I want the 7 to go away. So I'm going to add 7 to both sides because negative 7 plus 7 is 0. That's why I do it. And so I'm left now with just negative 12x equals negative, looks like what? 22. And then again, yes, division is appropriate, but I'd like to retrain us. And we're going to multiply by negative 1 over 12. Now, when we write this, like we know what we're about to do, so it's not a big deal. But notice what I wrote looks a lot like negative 1/12 minus 12, when in reality, what I'm really trying to say is that we're multiplying. So it would be appropriate to probably put that in parentheses as well. All right, so then I'm going to multiply this side by negative 1/12. I don't necessarily need parentheses around the negative 22 because I don't have this any misleading anything in between these to make it seem like it's anything but multiplication. All right. And that negative and a negative makes a positive. The 12s cancel. I get x equals. If you hadn't multiplied by a negative 1/12, you'd still have a negative over there. A negative 22 and a negative 1/12 is positive, and that gives me 22 over 12. But I see that those are both even, so that will reduce. 2 goes into both of them, and so I get 11 over 6. All right, moving on to part B. Always, always, always move the thing, deal with the part that's being added or subtracted first. And so we are going to simply add 12 to the left side and add 12 to the right side. Combine like terms, I get x over 4 equals positive 2. Let's multiply by the reciprocal. The reciprocal of 1/4, because when you look at x over 4, I want you to think 1/4 x. Okay, so in this case, we're simply going to multiply by 4 because the reciprocal of 1/4 is 4 over 1. The 4 on top cancels the 4 on the bottom. I'm left with x equals 8. We can always check our work. Just drop the 8 back in. 8 divided by 4 is 2. 2 minus 12 is negative 10. That's the correct answer. All right, let's keep rolling. All right, this problem, again, we really should be trying these before I do them, so hopefully you pause the video and try this. This one's interesting. A lot of kids are going to get this one wrong because they're going to kind of forget the cardinal rule that this minus sign right here, this minus sign belongs to the 15. So we're going to treat that as if it's a negative 15. Meaning, if I want this 9 to go away, I don't care what this says. This minus sign has nothing to do with that 9. So when I'm evaluating what makes a positive 9, right, it's a positive 9. What makes a positive 9 go away? That would be subtracting 9. Plus 9 minus 9 is 0. If you added 9 here, we'd have 18. So we just have to pay attention to the signs. This negative belongs to the 15, has nothing to do with the 9. Okay, so I'm going to subtract, and on the right side, I have negative 15x. And 54 minus 10 would be 44. So minus 9 would be one more, so that would be 45. And now I'm going to multiply by negative 1/15. Multiply by negative 1/15. And I get x equals a negative number. And then I have 45 divided by 15, which is going to be, I believe, 3. So I get x equals negative 3. All right, and I think our last example, sticking with our theme, deal with the add and subtract first. Opposite operation, I get x over 9 equals 2 negatives combined together, make it more negative. 7 plus 4 is 11. Now, again, I want you to visualize this says 1/9 x. So we're simply going to multiply by 9 on both sides. The 9's cancel. I get x equals negative 99. Check our work at any time. Plug that in. You get negative 11 plus 4 is negative 7. That is the correct answer. All right, that is it. As long as we pay attention to negatives and do the order correct, this should be hopefully a pretty stress-free assignment. We'll see you in class.